So next one is Rufino Oregon. So wherever you are ready.
My name is Rufino Oregon. I'm a technology management student at Texas A&M University in College Station, Texas. I work in a project called I work in a project to create a automatic grading system, and my mentor is Dr. Moreno, Dr. Alegre, Gerald, and Tisha. So the problem that we are trying to solve is that we want to create a automatic grading system that is able to grade submission from high school students in a class that is inside the VR Bytes program at LSU. These VR Bytes computational thinking assignments ask the student to create graphics using Haskell. And most automatic grading system uses unit testing. And an example of unit testing is that that an assignment asks for is expecting a specific result. In this case, let's say that the correct answer is 3.14, and the test is checking if at the end of the code the output is 3.14. If that is correct, if the output is 3.14, then it's correct. If not, it is incorrect. That is for unit testing. But unit testing does not work properly for graphical outputs. And here is an example of the code that the student produces, the high school student. So it's like from code, and then the output is a picture as this clock. The approaches that we are using is to use machine learning to create this automatic grading system. From the code that the students create, we can assign values, weighted values to some of the key features in the codes. That is the lines of code, functions used, quantity of variables, as well as the name that the variables has, the white space, comments, and the end result, which is the output image. So at the beginning of the project, I had to use SQL to retrieve URL links from the database, and these links goes to the server for the VR Bytes server, where the students' codes are stored. And then I created a Python code to automatically retrieve all of the students' code and create local copies in the computer. Until now, I created three methods of organization for the answers that we retrieve. So method number one, it creates a new folder where everything is going to be stored, which is the new data files. Then inside that folder, it has more folders. In this case, we have question and the question ID. We are working with question ID 1638, which allows the student to create the analog clock using the Haskell programming language. Then inside this folder, we have more folders which are named as max, underscore, and a integer. The integer is the max number that this teacher was assigning for this specific assignment. So we have different teachers that has different sections, and then teacher work in different high schools. The teacher has the power to choose how many points to give for this specific assignment, and that's the reason that we have different max possible values. Inside each of the folder, we have more organization. So if after we go to max 5, we have three folders, which is question, the question ID, and then another integer. The integer means that the files inside that folder were given the integer. So in the first folder, all the files that are inside, they obtain 3 points out of 5. And then the same for the other ones. All the files here got 4 points out of 5. And then also here is 5 points out of 5. That means that they got 100. And it looks like this. On the left, the first number is just a count. Then the number in the middle is the student ID. and the N is 1638, which means the question ID. And that is method one. That was the first method that I created. Then I created the method number two, which is similar to the first method, where the program creates new data files, then question with the question ID. But now the folders here are named differently. The folders are named using the teacher's username. Then if we go one of them, in this case, we go to Coleridge, it has three folders. So the first string is the section number, the section ID. Then the integer on the right is the max grade that they were giving for this section. So if we go into one of them, let's say we go to the first one, it has more folders, which are named score, underscore, and then a integer. The integer is the grade that was given. So if we go to score 15, all the files inside, they were given 50 points out of 15. In this case, there's a folder for 20 because the teacher gave one student 20 points. Maybe that teacher gave extra points, or maybe she did a mistake. But for some reason, there was one student that got 20 out of 15. Then the third method is a little simpler. So it again creates new data files, then the folder question with the question ID, and then it has all the answers that we retrieve from the server into that folder. But additionally, I create a CSV file called clock data features. In this CSV file, I have information from the teacher, which is uh, teacher ID, school name, section code, and the student ID. Then I have the submission link, so that goes to the server where you can visualize the student's code for that specific record, then submission time, then file name that it was given locally, and then the rest was it's part of the other mentor that I have from Tisha. Tisha created a Haskell parser to understand the key features from each of the submission that I combined her code to mine. So these other columns from field age to the right. So lines of code, variables, operators, rotated function, complexity, and comments. These are obtained from Tisha's code, and the values are given depending of each of the records. If the code has a lot of code lines, so it has very little. It has moderate. So moderate means that it is a good amount. More means that it has little lines of code, so it needs more. Then over here we have is clock right in field N, and then in field O we have creativity. So after this, Tisha and I had to manually grade all of the answers that we retrieved, because we concluded that some teachers do not spend proper time when grading, and if we use submissions that do not deserve 100, it's going to mess up our machine learning algorithm. So we spend some time grading manually. Then after we finished reading the 348 valid codes, Tisha used this new data with the grade that we gave to create a new program that is able to grade this specific question that asked for the high school students to create a analog clock. In the latest results, we have these are the four methods that Tisha prefer, and from what we can see, all three of them are very successful in being 95% correct when grading 70 samples that we use for testing. So we are doing good on this part. And as a little summary for what I have done is that from SQL database, I use Python to analyze the answer files, create organization methods that then they were used to feed into the program called Weka on the machine learning. And for the future work, we are planning to create a script that is able to create more correct and incorrect answer samples for this specific question. And this will increase the amount of data that we have that can be used to teach the method and also to test it. Additionally, Tisha will continue working on this project here and there in LSU, aiming to create an algorithm that is able to create this question even more successfully, and then integrate this, use these same steps to be able to grade other type of questions related to this one for the assignments that are in this program, in the VR-based computational thinking class, and integrate her code to save time to teachers when grading, and also to give feedback to the students instantly. So thank you for your time and attention. Is there any questions?
Are you going to be continuing with your partner, or is she just kind of taking over?
I'm going to be able to continue working with her a little more. I don't know how much time I'm going to be spending on the project, but she's going to continue working hard on this project, and I'm just going to be giving her a little more support as I can.
Any other question or suggestions, comments? Okay, there's no any other question. Let's Rufino. Okay, and our last speaker is Max.